Welcome back, everybody. Today we are going to be starting 9.2, surface area of prisms and cylinders. If you remember back to 9.1, with the solid figures, we talked a little bit about how to classify and name the solid figures, and tonight we're going to be doing a few calculations with the surface area. So the very first thing I want you to do is I want you to write down these three words: prism, surface area, and cylinder. Pause now so you can write it down. Okay, a prism. A prism is a polyhedron with two congruent faces that lie in a parallel planes. If you remember polyhedrons are formed by four or more polygons that intersect at their edges. But just remember, a prism, you're going to have different types of prisms. Today we're going to be talking about both rectangular and triangular prisms, but the formula for both all types of prisms are going to be the same to find that surface area. The surface area is the sum of all of the areas of its faces, all of these combined. Two ways we can figure it out. You can either make a net and add them all together, or you can use the formula which we are going to use tonight. And cylinder is a solid with two congruent circular bases that lie in a parallel plane. If you think of a cylinder, think of a can of pop, think of a can of soup. Okay, those are going to be your cylinders. First one we're going to be talking about today is going to be the surface area of a prism. In order to find the surface area of a prism, we take 2 times the area of our bases, okay, plus the perimeter of our base times the height. So the biggest thing is the area. What is the area of our base? Okay. Also, what I want you to notice is when we write it out in a formula using symbols, our formula have a capital B and a capital P. That's referring to that you need to find the area of the base with the capital B, and capital P means the perimeter of the base, not the perimeter of the object. You're finding the perimeter of the base. So going into our first one, it says find the surface area of the prism. So if you want to give this a shot, you can pause now. Otherwise, I'm going to go through this and follow along with me. Okay, so now finding the surface area of the prism. Remember, in order for us to find surface area, our surface area is equal to 2 times the area of the base, remember capital B, plus the perimeter, capital P, of the base, times our height. So if we look at this rectangular prism that we have here, notice that we have 9, 7 on the other side of this here, 9, and we have a 7 down here as far as our base. Okay, so now we're going to take 2 times the area of our base. Well, we know that in order for us to find the area of that base, we need to take base times height. So that's where we get 9 times 7. Also, in order for us to find the perimeter of the base, we have to add everything, all of the sides up on our base. So we have 9 plus 7 plus 9 plus 7. Okay, times our height, which is 14. Okay, so now when you're walking through these steps, this is the initial step that I want you to be able to write down. Can you interpret that formula and be able to write the correct numbers in for those variables? Okay, so now when we multiply this out, we get 2 times 63, because 9 times 7 is 63. 9 plus 7 plus 9 plus 7 is going to be 32. Multiply that by 14. Continuing on with our work, we have 126 plus 448, which is 32 times 14. Again, you can use your calculator on these problems. Then when we add these two together, we get 574. Now, the question is, what is our unit on these prisms or on these cylinders? It is surface area. Remember, the key word there is area. So we know the area have squared units. Okay, so our units are feet. Because it's surface area, because there's that area there, we have feet squared. Okay, feet squared. All right, and that's how it is. Let's try the next one. This one, it says find the area of the triangular prism. Now, before you start this, I do want you to notice when we have to have that formula of 2 times our base plus our perimeter of our base times our height. Well, we know that the perimeter of our base, we need to add up everything on the outside of our base. But notice, we don't have this length here. Okay, we can't just plug in 18. So think to yourself, how could you find that segment there, that hypotenuse? Remember, look at that, 90-degree angle. So how could we figure out that hypotenuse? If you have an idea, give this one a shot. Pause now. All right, so if you remember, we can find that hypotenuse by our Pythagorean theorem of a squared plus b squared equals c squared. If you thought about that and knew that right away, give yourself a nice little pat on the back. If not, don't worry about it. You can remember it right now. Okay, so now we have our a squared. I'm going to plug in 9 squared plus 12 squared is equal to c squared. When we add these together, you're going to get 81 plus 144, which is equal to 225 equals c squared. Now, how do we get rid of that wonderful squared symbol? If you just said square root, you are correct. All right, so take the square root of each side, and we get our side length of 15 centimeters is equal to c. So we know that this length, that hypotenuse there, is going to be 15 centimeters. Okay. Now that we know that, we can plug everything else in. That's a C, not 150. Okay, so it's 15 centimeters here. Now that we know everything, please go through this one and try to figure it out. Pause now. All right, hopefully you got that one figured out. We'll check it out now. 2 times the area of our base. Well, our base is a triangle. So how do we find the area of a triangle? You're right, half times base times height. So when we plug in, we have 2 times, again, half times base times height. Half, our base is going to be 12. Our height on that triangle, not on the prism, on the triangle, is 9. Then we have our perimeter. Our perimeter is going to be, we're adding it to the perimeter of the base, 9 plus 12 plus that segment that you just found, which is 15. Then multiply that times the height of the entire shape times 18. Okay? You're not multiplying where this 9 is right here. That's the height of the base, not the height of the overall shape, but the height of the base. Now, when we multiply all of these out, 2 times half times 12 times 9, you multiply it straight out, you get 108. Then, 9 plus 12 plus 15, what is that going to be? 36. When we add 9 plus 12 plus 15, we get 36. Then we need to multiply it times 18, and we get 648. Add these all together, 756 centimeters squared. Remember, units squared. We're still finding the area. All right? So if you got 756 and gave it a shot, awesome. Give yourself a pat on the back, and we'll move on. Okay, the next one is going to be finding the area, and this says a prism. It's not a prism. This is finding the area of a cylinder. We just found the area of a prism. This one's find the area of a cylinder. Okay, or surface area of the cylinder. Pause now, write this down. Make sure you get this bottom piece, because this bottom piece is going to be the most important. So pause now, write it all down, but try to memorize that surface area equation. Okay, again, it says 2 times the area of our bases. Well, because we have a cylinder, remember a cylinder looks similar to this. It's a can. Notice our bases are circles, so in order for us to find the area of our bases, we take pi times r squared, because that's our area of a circle. Then If you look at circumference of our base, that's the same thing as finding the perimeter of the base, except this one's going to be 2 pi r. Again, 2 pi r to find the circumference and multiply all of that times our height. Alright, so let's give one a shot. Actually have two problems today, but this first one you don't need to write down. Just let me show you, and then the second one you can write down. So notice again, no yellow bar at the top. Lucky you. Mr. Sheeman gets to do all of the work. Okay? Alright, finding the surface area of a cylinder. If you remember, we need to find, in order for us to find the surface area is equal to 2 pi r squared plus 2 pi r times h. Okay, again, we find 2 times the area of our base plus 2 times the circumference of the base times the height. Alright, so now plugging in what we know 2, we know our pi, and we have r squared. R squared is going to be 8 squared. Again, this is the diameter, so we need half of that segment, which is 8. Plus 2, again, we plug in our 8 here. Okay, and then our height is going to be 10 inches. Alright, so now that you have all of the numbers plugged in, normally when you start multiplying through, it does have a pi in there. So as I walk through my steps, I'm going to keep that pi in there until the very end. I don't want to multiply times pi too early because my numbers might come out a little skewed. Okay, so when you take 2 times pi times 8 squared, again 8 squared is 64, multiply 64 times 2, you get 128 times pi. So I got 128 pi. Then 2 times 8 times 10. 8 times 10 is 80, times 2 is 160, again 160 pi. Notice I keep the pi in there. Of course, not the wonderful pi that you get at Baker Square, but you keep the pi in there just to get a more exact answer. Now we can multiply by pi. 128 times pi is 402.12. I round to the nearest hundredth. And then you take 160 pi, which is 502, again, rounding to the nearest hundredth. Add these together. When we add these together, we come up with 904.77. This is inches squared. Again, we're still finding the surface area. It is going to be our units squared. Alright, so as you walk down, you plug in what you know. Then multiply it and simplify the answer. Again, simplify it to where you're not multiplying by pi right away. Then multiply by pi, then add them together, trying to get the most exact answer possible. Alright, so this next one, I want you to try, see if you can figure it out. Take time now, pause it, and write this problem down. Find the surface area. Alright, so now we have our surface area. Again, how do you find the surface area of a cylinder? All starts with that initial equation. Do you know what that initial equation is? Okay, what is that initial equation? Let me hear it. Alright, hopefully you were screaming at your computers, because it is 2 pi r squared plus 2 pi r h. Okay, 2 pi r h, 2 pi r squared. That is how you find surface area. Where do we get those numbers? Well, we took 2 times our area of our base plus our circumference times our height. That's why we need to do the areas from last chapter. So we have our 2. I'm going to plug everything in. 2 pi times 11. How did I get 11? Well, that's half. Remember, 22 centimeters is our diameter. We only want half. We want our radius. Okay? Plus 2 pi, again, times 11, times our height of 14. Okay? We're going to simplify this down in terms of pi first. So 11 times 11 is 121, times 2 is 242 pi. Okay, simplify it down to an answer of pi. Then 2 times 11 times 14, when you multiply all of that out, you get 308 pi. Now what do we do? Well, now we cut out that pi. Okay, I wish we could eat it. But then we have 242 times pi is going to be 760. And again, I'm going to round to the nearest hundredth to get a more exact answer. Plus 967.61. All I did was take those two numbers and multiply it by pi. Okay, then adding these two together, you get a very, very large surface area. Apparently, this cylinder was huge because you get 1,727.88. What's the unit? Centimeters squared. Absolutely. There you go. Okay, so we have centimeters squared. So again, today what you learned, you talked about surface area of prisms. You talked about the surface area of cylinders. Can you find those? Remember, when you find the surface area, especially of a triangular prism, you might need to take one extra step using that Pythagorean theorem to find out your answer. We'll get our homework later, and I'll see you soon.